Okay, so determine ID and VD for IX equals 7 milliamps, right? So IX is now 7 milliamps. What? Was that not right? Okay, I thought I heard something. Okay, so IX is 7 milliamps. We can write 7 milliamps here, right? What can the diode behave like? Are there like many different things? An open circuit or a? Absolutely not. We didn't even cover that model, really. We didn't dwell on it. Open circuit or? Nope. We covered one, we focused on one model in our class, which is what for a diode? What does the IV curve look like? Large signal model. Open circuit or a voltage source, right? If you go elsewhere and they talk about ideal diodes, that is true. It's going to be open circuit or short circuit, right? And long cap, I emphasize those. But as far as lecture is concerned, we said we're focusing on the large signal model, right? Where this is turn on is 0.7 volts, right? Okay, so we can think for a second. Our first test is imagine this is an open circuit, right? I don't like, honestly, I don't like the way Professor Brunet does the videos. I mean, they may well work, okay? I would never do it myself like this. And I think it's a good way to start that way, but maybe move past it, to actually erase the diode and replace it with a voltage source, okay? Because the diode acts as a voltage source, but there's no need to replace it. How would we replace it? We could just do it, you know, we could just write 0.7 volts, right? Without erasing the diode or rewriting the circuit, okay? And this kind of on-circuit analysis will definitely take you farther, okay? So the other thing, it works. You know, Professor Brunet is not doing, in my opinion, anything wrong at all. She's teaching you kind of giving you a little bit of a stool, right? Of a crutch, right? But if you can move past to this, that's fine. But right now, let's just assume it's an open circuit. So you do a visualization or use your hand, okay? Open circuit, then this is 7 milliamps. What, if this diode is an open circuit, what is going to be the voltage drop across the resistor? The voltage drop across the resistor is going to be 7 volts, right? Okay? And 7 milliamps times 1 kilo ohm, 7 volts, right? That's going to be the voltage drop, okay? So in this case, we can write the node voltage here as what? -2. Okay? All right. And then we check if everything is consistent. -2, will indeed the diode behave as an open circuit? If you connect -2 volts here? Is it forward biased or reverse biased? Reverse biased. So yes, it is an open circuit, right? So there's a solution. So if this is -2 volts, this is a consistent solution, right? Okay, so it's turned off. Okay, so what's diode voltage? What's the voltage across the diode? That's what's being asked. What's the voltage across the diode? -2 volts. And what's the current through the diode? Voltage across, current through. Okay. The current through the diode is indeed 0. We don't need to give units to the 0, but we can. Okay? All right. So, what about when the current is 4 milliamps? Let's start with the same assumption. Okay? Let's say, okay, diode is an open circuit. Diode is an open circuit. What is the voltage drop across the resistor? 4 volts. What is the voltage here? 1. And what's going to happen to the diode? Okay? The diode now is forward biased, right? So what is going to behave like? Okay, it's going to behave like a voltage source. So now we can write 0.7 volts on the diode. Wait a second, we've just come to a contradiction, right? I just wrote 0.7 volts across the diode, going like this, right? And I'm going from ground across the diode, there's nothing else above it. But then I also wrote 1 volt. Which one's right?
1.
Which one's right? Let's vote on it. How many of you think the 0.7 volts of this node is correct? How many of you think 1 volt is correct? Okay, about 50-50. All right, of those that voted. What was one volt based on? It was based on an assumption. What was the assumption for the 1 volt? That the diode is turned off. Is that assumption true?
No.
That assumption is not true, right? So that voltage is not true. Okay? That voltage is not true. The assumption was that the diode is off, all the current through the resistor is going also, is driven by that current source. Okay? And that was our assumption. But our assumption led us to turn on the diode. Therefore, the assumption was wrong. Right? Therefore, the diode stays turned on, and we mark this as 0.7 volts. Okay? So the voltage across the diode, when the diode is turned on, 0.7. This is the large signal model that you guys are studying. Okay? Independent of anything. It's turned on, it's 0.7. So that's 0.7 volts.